So recently I was watching a show about 3D printing rockets and stuff, and actually the 3D printing metal was significantly weaker and for the outside layer for the mass, and that's because they have all these little bumps because they're putting it layer by layer, which leads to bumps either from a bunch of strings being printed out like layer by layer like this, or that they print a bunch of little particles. And these little bumps here do not support the structure. So how do we fix this so we can save a lot of material mass? Well, I've come up with about 5 ways. One is to have a bus that smooths it out. Now you can have a spinning, now you can combine all these technologies, of course. So you can have a spinning bus that spins and kind of flattens it out and removes some material from here and puts it over here, and vice versa, like a polishing thing. Or you can remove the material and just recycle it, just spray it off and not move it into place. Another one is just a bus that moves back and forth very quickly, perhaps using like an ultrasound or something. Another technique that is used is hot busing, where you have a bus that is very pretty hot locally, and that hot bus can do a couple things. Either you can just remelt it, or the material becomes a lot softer where the bus is hot when it's rubbing against it, so you can more easily just rub stuff off from here and place it into these little gaps. So that's hot busing. The other thing that hot bus can do is you can actually make the bus out of material that it coats more easily. Like if you have steel, you can hot bus brass on. So you have just a brass bus, and that will fill in little pieces of brass in these little gaps. As it kind of busts off and it kind of melts together. It's not exactly really melting, but then you can also just bust in material without heat or something. Or if you have a bus, you could do micro welding, where you put a little bit of electricity, and these little electric charges go zzz, and when it hits metal here, it heats up the metal very locally and melts it and welds it to the next piece of metal here, like a surface finish, or an arc that does that. Another idea is to have for the second ideas and after busting is you can use hot air, liquid or spray, to compress this and fill up the gas and possibly melt it. Now you don't really have to melt it. The hot air itself just needs to hit it and make it deform more easily. Now, if you want to make this even better, the hot air, you might not use air because air oxidizes. You could use nitrogen, or you could use hydrogen or fuel-rich source of a welding, like something with too much gas in it compared to oxygen, and that could remove some of the surface oxidation, which can decrease performance. Because when you're melting stuff, a little bit of oxygen can mix in, which can decrease performance. A common way to help prevent this is actually add borate and borax to it. You could also just use a spray with a bunch of things mixed together, and the spray could have solids also included into it. And the reason why a liquid or a spray might be because they can heat up stuff with a lot more fast. Hot air doesn't heat up stuff as nearly as fast as hot liquids, and spray could do even more. Also, all these things can not only give, also spray you can give more force and it spreads out less easily, so you can focus it more into a little spot or liquid. And you could also add like abrasive materials to the spray or to liquid, and with liquids you could cut out stuff into the shape, so you could lead to a whole new milling device with different settings. And this could also just work with abrasion, of course. Another one is, instead of spraying stuff to remove stuff or remelt stuff, is you could spray in materials to fill in the gaps, like a very expensive epoxy. Some epoxies and plastics are incredibly strong, stronger than metals, but you could spray them into cracks. Now they're more expensive and it's harder to fabricate, but maybe they could fill up in cracks. The fourth idea I have is what I'm going to call chemicals, to just either make a chemical reaction that expands certain parts, flattening it out, which is hard to design, but you could design it. Or besides the chemicals, you could have the more wasteful chemical step of it dissolving away some of the metals more selectively to give it a different surface finishes. Now, normally when you have something dissolving away the certain parts of the material, it's going to dissolve away the inside the crack first because there's a higher surface area here, and not make it flat and just separate it. However, you can make it flat if the liquid actually forms a bubble. It doesn't reach the crack in it. It's forming a little bubble on top of it. That bubble on top of it is going to eat the top layer first and smooth it out, which is a technique for polishing. Chemical ideas could also be combined with a spray idea from before and two very easily, and also could make it rougher so you could spray in materials better. Now the last idea is stamping. And stamping would work simply is that you have your material here, you have something here that is holding it in place, then you have something on the outside, and you just press it together. Now that pressure could also come from air, it could come from a liquid, hydroforming, aeroforming, or it could be two metal things that is pressed together and presses it and fills up that gap. And pressing can actually make a metal stronger than normal, regardless of the smoothing out of the material. Well, thank you very much for listening. I hope you found this interesting. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Again, thank you very much. Goodbye.